in chemistry, we measure things in grams if we want to know the weight of it, or in centimetres cubed or decimeters cubed if we want to know the volume, the amount of space it takes up. But if we want to know the amount of something, then we use something called the mole. The mole is a measure of the amount of a substance. And it is just a number, a mole. So it's the same way that if I had a pair of something, then I'd know I have two. So if I had 2 pairs of socks, then I'd have 2 lots of 2, I'd have 4 socks. Or if I had a dozen of something, then I know that means 12. So if I had 2 dozen eggs, I've got 2 times 12, which is 24 eggs. In the same way, a mole is just a number. It's just an extremely big number. So the mole, the number is 6.02 times 10 to the power of 23, and that's approximately, I've just rounded that there, it's actually something like 6.022140076 times 10 to the 23, so we round it to that. That's an incredibly big number. I've written it in standard form there, because if I was going to write it out in full, it would take ages, so I'll do it now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That hopefully shows how incredibly big this number is. This number is called the Avogadro constant. Avogadro. Or the Avogadro number. And Avogadro is a scientist who developed this. To give you an idea of the size of this, because this is far too big a number to actually really get your head around. If we had 1 mole of peas, you know what a pea is? It's a very small little thing. If I had that number of peas, they would cover the entire Earth to a height of 600 meters, which is taller even than the Empire State Building. So it's an incredibly big number. Or if you had that number of pounds and you spent £1 billion every second, it would still take you millions of years to spend it all. So it's a number that's far too big to get your head around, but that's what a mole is. We can work out, using this number, the amount of particles in something if we know the number of moles. So this is the first thing that we'll be working out, number of particles. And see that, if we know the number of moles, we just times it by the Avogadro constant. Sometimes the Avogadro constant is given this symbol N with a subscript capital A. So that's what I'm going to use just to make it easier to write out. So, for example, if I was told that I had 2 moles of water, 2 moles of water is roughly a mouthful of water. And we know that water is H2O. Then the number of particles is 2 moles, so it's 2, times the Avogadro constant. And I'd find that I've got 1.204 times 10 to the power of 24 particles of water. Now, let's just be clear on what the particle is. We know that water exists in molecules, H2O. So that is the number of molecules of water in 2 moles of water. If I wanted to know the number of atoms, then we've got to realise that there are 3 atoms in every molecule of water, so it'd be 3 lots of that. And the answer to that one is 3.612 times 10 to the 24. So that's the number of atoms in roughly a mouthful of water. Okay, just rearranging that, if we knew the number of particles of something, we could actually work out the number of moles of it. So, working out the number of moles, if you imagine we just divided both sides of this equation by the Avogadro constant, the number of moles is the number of particles divided by the Avogadro constant. So for example, if I was told that I've got 1 times 10 to the 18, so a billion particles of something, and I divided that by the Avogadro constant, I'd find that I've got 1.66 times 10 to the minus 6 moles, so a very small number of moles of it. And the units for moles, instead of writing the word moles, we shorten it to mol, M-O-L, like that. Okay, so that's the second thing we could work out. One other thing I'll just quickly show you how to work out that uses the Avogadro constant is we can work out the mass of a single particle. And that's because the relative formula mass tells you the amount of grams that 1 mole of a substance would weigh. And I have made a video about relative formula mass, so if you've not already seen that and you're not sure about relative formula mass, then you're welcome to watch that. So for example, if we went for a water molecule, we know that the relative formula mass of a water molecule is 18. And we're going to do the relative formula mass of it to find the mass of just one particle. I just divide that by the Avogadro constant again. So in this case, if I'm using the example of the water molecule, I would do 18 divided by 6.02 times 10 to the 23, and that would give me that the mass of a water molecule is 2.99 times 10 to the minus 23 grams. So an incredibly small number this time. That's how much one single molecule of water would weigh. So when we're talking about the number of moles, it's just the number of particles, and we talk about moles instead of particles because it's such an enormous number that we're dealing with.